Good evening, everyone, and welcome to another hour of Healthy Conclusions, where we try to give our listeners important information on nutrition, exercise, and holistic alternative and integrative medicine. Please take a minute to visit our website at www.healthyconclusions.com and like us on Facebook. My name is Bob Nugabar, and I will be your host for this evening's show. Tonight's show is being brought to you by Altrua Health Share, which has been serving its members and their families with their health care needs since 1997. Please take a moment to visit their website at altruahealthshare.org or call 888-244-3839 to see just what Altrua Health Share can offer for your family's health care needs. It could mean substantial savings. Our guest for this evening is Dr. Stephen Iqbani, or as the Californians say, Iqbani, who is a former award-winning MD Anderson oncologist. He received his medical degree from University of California, San Francisco School of Medicine, and has been in practice for more than 40 years, with his specialty being hematology oncology. Dr. Iqbani is currently associated with the Karfeld Center Integrative Clinic here in Meridian. Good evening, Dr. Iqbani, and it's a distinct pleasure to have you here with us this evening. You have a very interesting background in that you served your fellowship at a prestigious MD Anderson Cancer Center in Houston, Texas, receiving the Outstanding Researcher Award and presenting your findings at the American Society for Clinical Oncology. You co-founded St. Mary's Regional Cancer Center in Walla Walla, Washington, and you were also the medical director for the Kootenai Cancer Center in Coeur d'Alene, Idaho, and are an author of a book, The Undying Soul, which relates to stories of real people fighting cancer. A doctor who gallantly fought beside them, which I presume is you, and what he learned from them along the way. You have also worked in Mexico at the Gerson Clinic, CHIPSA, which is an integrative clinic, and we've had Gerson's grandson on our show about 4 or 5 months ago. So let's get into some of the questioning on some of the things you've been doing. Dr. Iqbani, would you say that you have moved from the allopathic model of medicine in oncology to a more integrative approach, or even a naturopathic approach, in your treatments and research? And why did you make that move in that direction?
Well, Bob, it's a real pleasure to be here with you this evening. Thank you so much for having me on the show. We use the word integrative, I think, appropriately to mean that we aren't going to do one thing or the other, but we're going to integrate allopathic and homeopathic and naturopathic. And so I'm still an allopathic physician. I practice allopathic medicine in my practice. But I integrate into my practice things that I've learned from the naturopathic world that I think are very beneficial to patients.
And what types of things do you integrate?
Well, I'm a medical oncologist, hematologist, and so the great thing about that subspecialty is that we actually take care of the whole human body, because cancer and blood can be anywhere in your body. If you're a kidney doctor, you take care of kidneys. If you're a heart doctor, you take care of the heart. And we need those specialists because those are complicated organs. But cancer isn't an organ. It's a thing that travels around the body. And so in that sense, also, because part of the business in allopathic oncology is to take sick people and make them sicker with poison, it seems incumbent upon the practitioner to do what he or she can to mitigate those effects and make the person healthy before, during, and after chemotherapy. I find that not as many practicing oncologists focus on that as maybe would be optimal, shall we say.
Well, I can surely agree with you, having been through that scenario in my life several times. You've been involved in some very interesting emerging technology, and as I understand it, you have been heavily involved in the research of something called photoillumination. Could you explain in layman's terms what that is?
Well, it's extremely exciting. I think it has a huge future in healthcare, and it is just starting out. It could be something like the silicon chip, but the future is there to be discovered, and we can only speculate. But to make it simple, what I tell people is all energy on Earth originates from the sun, doesn't originate on the Earth. The one exception to that, I suppose, would be geothermal. But in terms of life forms, plants and animals and humans, we get our energy originally from the sun. Light travels across the solar system to our planet. And this light energy is absorbed by plants. And plants convert this light energy into chemical energy, which they use to grow and nurture themselves. And then they come along and get consumed by animals who convert that chemical energy into their own chemical energy. Our bodies run on chemical energy. And so it turns out, however, that the way that light energy is turned into chemical energy in the plant is nearly identical to how chemical energy in humans is converted into other forms of chemical energy that can be used. So, for example, energy is an interesting thing. You have to take energy and you have to break it down into usable portions. So, oil comes out of the ground. You don't just pump oil in your car. It has to be refined into gasoline. And so, we've been powering our combustion engines with gasoline for 100 years or more. And now all of a sudden we can power these same machines with electricity, because once you generate power of one form or another, the wheels turn. And so in that sense, it's not terribly surprising to understand that if we could somehow inject light energy into the human body, that it would have marvelous energizing effects. And it just so happens that we now have that technology. This is something that has been coming along for the last only 10 years or so. But we can now, with the use of fiber optic cables and light adapters, we can insert a cathode into your blood vessel, and the blood flows over the cathode, and the blood receives light energy directly. And so the health benefits and healing power of this new treatment modality is yet to be discovered. It's somewhat analogous to electric cars. All of a sudden may change the face of automobiles, and this may have a dramatic effect. This light therapy may have a dramatic effect on many areas of medicine and healing.
So I understand that this is a treatment that is still in trials, and there are only about 80 of these machines in use in the country, but that this therapy has been approved for use in Europe, where most of the research was done, but is not yet by the FDA, has not been yet approved by the FDA. Is that correct?
That's right. So one of the reasons why I'm involved in this is because I already practice oncology almost full time, and so I'm not in the business of setting up a photo illumination clinic and running it full time. But the fact is that the treatment has not yet been licensed for general use in the United States, and so there are only a limited number of us who are actually able to do it or licensed to do it. But the treatment actually has been used worldwide, over 100,000 patients, and so the safety and the efficacy has been well demonstrated, so much so that the equivalent of the FDA in the European Union has now licensed it for general use, and any practitioner there can acquire a machine and use it for their patients.
Are these expensive machines?
They're not cheap, but in terms of medical technology, they're not terribly expensive. They're a lot cheaper than most machines, such as X-ray machines and mammogram machines and so on. The nice thing about it is that they're inexpensive to operate, and if, for example, we had third-party payment, we could treat people with this very non-toxic and healing treatment for very little money. And it's not a drug. It's light.
Well, we're working on doing some of that. Could you give us a general idea of how you became interested in this new therapy, and what is it currently being used to treat what diseases?
It turns out that light therapy was used to treat bacterial infections before the advent of antibiotics. And so there was a whole world war called World War I that occurred before anyone had ever invented an antibiotic. And there were men strewn throughout the clinics of France and Germany and elsewhere, laying in clinics with open wounds, and the only treatment that was available to them was to shine a light bulb on the wound.
Okay, I'm going to hold you right there for a minute. We're going to take a quick break. We have to take a quick break. We'll be back in a few minutes. You're listening to Healthy Conclusions, brought to you by Altrua Health Share, with your host Bob Neugebauer on 580 KIDO AM and 107.5 FM. Welcome back to Healthy Conclusions on 580 KIDO AM, 107.5 FM. We are speaking with Dr. Stephen Iacoboni, who is with the Karlfeldt Center here in Meridian, and we are sponsored by AltruaHealthShare.org. So you were talking about World War I and how they were using light to help heal people. Is that correct?
That's right. Before there were antibiotics, the only thing we could use to sterilize tissue was light. And in fact, if you had an open wound, they couldn't close it because it would get infected, so they put a light bulb over your wound, and you had to lay there for a month for it to close up and heal. Whereas now, of course, with antibiotics, you close the wound and you give antibiotics and you're out of the bed a lot more quickly. The point of that is that we know that light kills bacteria and, for that matter, viruses. The other thing that light does is that it has the potential to stimulate the immune system, which is how I got interested in this, because I'm an oncologist and I've been practicing for many, many years, and you can imagine that I have seen many, many, many patients die from their disease. And the most frustrating thing in the world about cancer medicine is that we actually are very, very successful up to a certain point, and then we stop before the finish line, meaning if you have stage 4 breast cancer, for example, there's an 80% chance that you can be put into remission, meaning that you have we've killed 99% of your cancer. There's also a nearly 100% chance that you'll die from that same disease even though you went into remission, which means that we are 1% away from cure. And we've all been beating our heads against the wall with this dilemma, with this impasse, with this obstacle, for the whole 35 years that I've been practicing. So, what it means is that we have to come at it from a different direction. We can't just keep doing more of the same. They bombed Iwo Jima for a month. It didn't do any good because the men were underground. So if you keep dropping bombs on people forever and you're not hitting them, you're not doing any good. So the light therapy, the first thing that excited me about it was its potential to activate the immune system. And that might have major potential in treating cancer patients who are otherwise terminally ill.
So this may have, at some point in time, an effect in the cancer industry should they prove the efficacy of this particular light therapy. Is that right?
Right. Now, I'm not here to say that I can make any claims about efficacy. You asked me why I was interested, and I said I was interested because I thought it has potential to do these things. And I will share with you that I have, in fact, treated a handful of patients who were otherwise failing therapy, who got the light therapy, and had dramatic results. Now, when I say handful, I mean less than 10, but more than one. And so for someone who's been looking through the haystack for 30 years for the needle, and then you spot the needle, that's pretty exciting. It is not statistically significant, I can't make any concrete claims about it, but I'm excited. I'm intrigued, and the great thing about the light therapy is it's absolutely non-toxic. I mean, this is not drugs. This is just plain light.
So you can use this for other diseases. What other diseases have you been using this light therapy for?
Well, the light therapy is known to kill any virus that's circulating in your bloodstream. It would be interesting to treat hepatitis C, but what's happened, of course, was that for many years the treatment of hepatitis C was very harsh. But they've come up with new treatments, so I'm not sure we'll ever have much opportunity for that.
Are we talking about something like Harmony?
Yeah, Harvoni works extremely well. It's expensive, but it's easy to take, and it works very well. Before Harvoni, the treatment of hepatitis C left a lot to be desired. Chronic bacterial infections, like someone who has a hip or knee replacement that got secondarily infected, and you have to keep taking the prosthesis out and take IV antibiotics for literally 3 months, and then the bacteria become resistant. These horrible infections can be cured with the light machine. It's quite remarkable.
Well, would this be able to cure something like MRSA?
Absolutely.
I mean, this is something that they,
the
have been
R in
having a problem with.
MRSA. The R in MRSA means resistance,
Right.
And what's it resistant to? It's resistant to the M, methicillin. Methicillin is the drug that kills Staph aureus. So MR means methicillin resistant, meaning you've got a Staph aureus that won't respond to most antibiotics and all penicillins, but that has nothing to do with the light. The light will kill MRSA on the spot.
So this can be used for bacteria that we have no real killer drug for.
Right. Fortunately, there aren't too many examples of bacteria. I mean, you can treat MRSA with other third and fourth line antibiotics, but they're very expensive.
Right.
They have side effects. Of course, C. difficile has become a big deal, and there are other bacterial infections that worry us. Because the heavy use of antibiotics in hospitals now has got all of us just cringing for the time when the resistance rears its ugly head.
Well, I think the problem also is that we're finding antibiotics in our water. We're finding antibiotics in our milk. We're finding it just about every place.
In your food.
Yes.
Yeah, right. That's how you can get a penicillin allergy from never taking penicillin, is you've been getting it in your chicken.
I can understand that. A chicken for every pot, and every chicken gets a little penicillin.
Right. That's agriculture.
No kidding. So light therapy could be considered old science with a twist of modern technological improvements through the use of laser light.
Right. So in the old days, of course, they just used plain light because that's what they had, whatever light came out of an incandescent bulb. Now, of course, we can split light with a laser. And the scientists who invented this technology, of course, investigated the different light wavelengths that have a particular effect on human metabolism. And they've identified 3 wavelengths. And so this isn't just a white light coming out of a flashlight going into your bloodstream. These are monochromatic, highly specialized wavelengths that each have a different function, a green, a red, and a low-energy ultraviolet. I wanted to get back to the question you just asked about diseases. The diseases that I think I'm most excited about treating, other than cancer, are the autoimmune diseases that we seem to be becoming more and more common. Like,
Are we talking about MS, Parkinson's, those types of things?
Well, we don't know about Parkinson's, but talking about sprue and lupus and Crohn's
Right.
and ulcerative colitis and rheumatoid arthritis and celiac disease, those kinds of things are autoimmune. And the immune system is a very delicate and tricky thing. But what the light does actually is it activates a portion of the immune system that is responsible for controlling the immune system. And so there's a very good potential to be able to treat these conditions with the light therapy. Now, again, that's all in trial. I'm saying that that's a theoretical possibility. What's happened in those diseases, if you ever watch television, is that they now have some very good conventional therapies for these diseases, but they're monoclonal antibodies, and they are hundreds of thousands of dollars. And so if we actually wanted to get to an economy where you could treat something for $1,000 instead of $100,000, we might want to rethink our therapies.
Well, as long as the drug companies are around, you're going to have a difficult position moving light therapy in behind drug therapy. At least that's what I've found out over the last 5 or 10 years. I'm familiar with the common use of UVB light, which is when the blood is drawn and exposed to the light and then reintroduced into a patient's blood system. But with this new system, you use 3 different wavelengths of fiber optic cable inserted into a blood vessel. Can you explain how that works and how you get the efficacy rather than having to take the blood out, put it back in, which I've seen happen?
Right. So in a lot of naturopath and chiropractic and homeopathic offices around the country, UBI is what it's called. You draw blood out of a patient and you run it through a machine that generates UVB light, which is medium intensity ultraviolet light. And the blood is irradiated and then reinserted back into the patient. That's been the state of the art for a number of years, but it has all sorts of shortcomings. It's sort of like a carburetor. We don't use carburetors anymore in cars. Reinserting blood into a patient is dangerous, and you only irradiate a small portion of the blood, the amount that you withdraw. And also you have to use very high energy ultraviolet light, UVB, and that has certain harmful effects, at least potentially. The laser light therapy that we use has lower energy ultraviolet light, UVA, and so it has no toxicity. And what's very interesting is once we insert the catheter into the bloodstream, we leave it there for an hour, and in 60 minutes, your entire blood volume has passed over the tip of the catheter, and every drop of your blood has been exposed to the light. And it's a very intimate exposure. In other words, you have a vein about the diameter of a pencil, and the blood is flowing over it in a vein, so it's flowing slowly, and it gets hit by the light, sort of as if I stuck a flashlight in your face for a few seconds.
Wow, that is amazing. We're going to come right back to that. Hold that thought. We have to take a quick break. We'll be back in a few minutes. You're listening to Health Conclusions, brought to you by Altrua Health Share with your host, Bob Neugebauer, on 580 KIDO AM and 107.5 FM. Welcome back to Health Conclusions on 580 KIDO. We're speaking with Dr. Stephen Iacoboni with the Karlfeldt Center in Meridian, and we're sponsored by AltruaHealthShare.org. So we were talking about how this light works, where you put the catheter in with a fiber optic line, and the blood flows over it. You mean you can actually sterilize and fix the whole blood system in 1 hour? It's almost kind of hard to believe.
Well, you can sterilize everything that flows over the catheter. Some infections, for example, HIV, the virus doesn't spend all of its time circulating in the bloodstream.
So is that the exception to the rule?
That really is the exception. Most viruses, like Hep C, is in the bloodstream. Common cold is in the bloodstream. Lyme disease is in the bloodstream. All parasites are in the bloodstream. Malaria, Chagas disease, and so on. So, and certainly if you had a MRSA infection, a lot of that, even if it was sort of in your hip, a lot of that bacteria really only hurts you when it gets out of the area of infection and starts running around your body, and releasing what we call toxins. The other thing that the light therapy does is it stimulates the immune system. So in your blood, half of your blood is water, and another 40% of it are just red cells, which don't have any immune function. They just carry oxygen. But your white blood cells, which of course are your immune system, circulate in the bloodstream. Now, only about 5% of your white blood cells are in your bloodstream, but that's still 100 billion cells.
It's a lot of cells.
It's a lot of cells, and the immune system is like the National Guard. It sits around waiting to be called up, but if there's no fire to put out or a flood to take care of or hurricane, they're just sitting there waiting to be called. And so mostly, especially in our society, which has very good hygiene and so on, and there aren't a lot of epidemics, your immune system's just sitting there, and it gets kind of lazy. And so it needs to be activated before it's going to do something. If you're a policeman with the night duty and you're waiting to get a call, you're waiting to get a call. And so what the light does is it sends energy into the cell and activates the chemical cascade in the cell, which turns the cell from dormant to active. And now you've got a police car with sirens blaring, and it's chasing after the bad guy.
That's an interesting scenario. What does the light actually do to the cells that are exposed to it? Help me to understand why you get this immune change in your system. What does it do to the cells?
So you can think of the immune system as, say, a police force in a country, and the police force has the job of getting rid of bad guys and preventing crime if they can, or dealing with it when it erupts. But they have to be notified that there's a burglary on 4th Street, or they can go knocking on doors asking people questions, depending on what's going on in their neighborhood. But there has to be a signal sent to the cell to say, you need to turn on your sirens and go after this guy. So everything in your body actually is based on chemical signals. We all know, for example, that insulin is the signal that takes your sugar out of your bloodstream and puts it into your cell. That's, I think, a chemical signal almost everybody is aware of. So the same thing is true with your immune system. They have to be activated. They have to get a signal. So, like I said, the light therapy is a jolt of energy. And this jolt of energy unleashes one of the main immune activators in the white blood cell, which is in its inactive state, is actually corralled by a chemical that won't release it, because it doesn't want you to have too much immunity, or autoimmunity, or hyperimmunity, or allergy. So the light energy gets into the cell and breaks the shackles off of the inhibiting molecule, and then the activating molecule goes straight into the DNA and tells the DNA to send out activating factors that cause the cell to activate, and it goes into action.
So it's kind of an immunomodulator?
It is indeed an immunomodulator. And like all immunomodulators, what you want is to turn on the immune system but not turn it on too hot. And so one of the remarkable things that they've determined in this research is we only turn on the immune system to the point where it's helpful. We don't cause autoimmune disease with the light therapy. In fact, we turn on... I was
going to ask you about that.
Yeah, we turn on the cells that turn off the immune system. In other words, in the immune system, you have cells that attack things, and you have cells that attack the attackers. We call them helpers and suppressors. And so in what we do is we turn on the cells so that they have a balanced amount of activation without overactivation.
So, I mean, there's a lot of different autoimmune diseases out there. So you can turn this up or on or off to whatever degree you want by the amount of time you leave it in, or by the light you're using. How do you figure that out?
Well, a lot of work, decades of work and research on animals, and then also human trials outside of the United States, were done working on the proper wavelengths and the duration of therapy. So that's all been pretty much worked out over, like I said, 100,000 patients worldwide, to where we know that it's very safe and they've chosen the right wavelengths. So everything in your body is extremely delicate, and so you can't, for example, make phony insulin and hope that it works. And you, for example, the disease that we call Chagas is activated by a parasite that has to do with the fact that the white cells just don't recognize it. So sickle cell anemia is a disease where only one amino acid out of 1,000 is misplaced. So they had to get the right. That's why you have to have monochromatic laser light, so just the right wavelength to give us just the right amount of energy to get the intended effect.
That's really interesting. So you're still doing research with this laser light and are just beginning to understand the many uses it might have with the different diseases. When do you expect that this therapy might be available on a much wider scale to the public?
It's a little bit hard to say. The only access I have to answering that question is the company themselves, and they have been telling us that they're very close to getting FDA approval, but now they've been telling me that for 2 years. I can say that since we're in phase 3, meaning
Phase 3 trials?
yeah, 3 out of 3. In other words, trials go 1, 2, 3. There aren't 10 phases. So we're in the last of the clinical trial phases. And so,
So you're part of those clinical trials using the machine,
right? The machine is licensed for the clinical trial. So everyone who gets on the machine has to qualify for the clinical trial. Although the qualifications are pretty universal. In other words, if you're in perfect health, we're not going to put you on the light machine. But if you have a chronic sinusitis or chronic fatigue, or you have an autoimmune disease, or if you have cancer, or if you have migraines, anything that's debilitating, or chronic fatigue, for example, hepatitis C, or tuberculosis, or malaria, anything that's debilitating, you qualify for the machine.
well, maybe you could cure my psoriasis.
Probably could.
Well, now there's a thought. We may have to work on that a little bit. Do you think this machine will make it easier to cure some diseases without the use of drugs?
Well, I really do think so. For example, we can cure bacterial infections with this machine. And the machine is no more cumbersome to use than antibiotics. In other words, it is a small device that generates the laser light, same as the machine that generates the antibiotic on a drip. You hook it up through an IV in the same way that you hook up an antibiotic to a drip. And right now it has been used with great success in certain medical centers where people have unresponsive infectious diseases. You know, if you can blow up the biggest bunker, you can probably blow up all the small bunkers with the same bomb.
So you're continuing to test this on different diseases as you go along. Is that right?
My interest is to help figure out what the best use of the machine are. The machine is being marketed mostly as a wellness device in Europe. That has to do with marketing factors. Of course, I'm an oncologist and I care about wellness, but what I care about is wellness in the person who has an illness, as opposed to just wellness in the part of a person who doesn't have an illness. Now, I think wellness for everybody is extremely important. I worry about my own wellness. I take care of myself. I'm just saying that professionally, I take care of sick people, and I want to see if I can make them better. And drugs can only do so much, and this is a whole other way of approaching the problem.
We have to take a quick break. We'll be back in a few minutes. You're listening to Health Conclusions, brought to you by Altrua Health Share, with your host Bob Neugebauer on 580 KIDO AM and 107.5 FM. Welcome back to Health Conclusions on 580 KIDO. We're speaking with Dr. Stephen Iacoboni with Karfeld Center in Meridian. We are sponsored by Altrua Health Share. So let's move on a little bit more here. I understand, Dr. Iacoboni, that you've been doing some ongoing research in the supplement protocol arena, where you would be including, in combination with chemo, some supplements that they have put together in a therapy that would be much more effective to overcome drug resistance while using the chemo. Could you explain to us how that would work?
Sure, I'd be glad to. As I mentioned at the opening of the program, what goes on in oncology is we're 99% successful, and yet we lose every game. In other words, we're ahead at the halftime 99% of the time, and we lose in the last minute. And so you have to ask the question, why is that, and how long are you going to keep doing the same thing before you decide to do something differently? The whole model for chemotherapy is to attack the DNA. And the idea is that the DNA in the cancer cell is the source of the problem. But every biochemist knows that what causes a cell to die, which is what the intention is of the chemo, doesn't come from the DNA. It actually comes from the mitochondria. Now, I don't want to get too technical here, but just I'm trying to point out the fact that
Well, the mitochondria actually create the energy in our body. Is that right?
they do, and they are also the cells that activate what we call apoptosis or programmed cell death. And so the goal of chemotherapy is to induce the mitochondria to induce the cell to dissolve and stop being a bad guy. In other words, tell the bad guys to surrender. But the problem is chemotherapy acts indirectly. It acts on the DNA, not directly on the mitochondria. It turns out it's been apparent to a lot of us who've been asking this question, well, why aren't we, as oncologists, attacking the mitochondria, since that's really the target? That's the immediate target as opposed to the indirect target. And part of it has to do with the way thinking evolved in oncology, and people are sort of set in their ways. It turns out that the mitochondria is very sensitive to some fairly not so complicated maneuvers that can be achieved with non-toxic supplements.
Are we talking things like vitamin C, vitamin E? I mean,
Yes,
just normal
yes.
everyday things.
Right. Yeah, and so I've been working with a group that has been studying this very carefully for a long time, and we think we have come up with a formulation that will get us over the last 1%. In other words, I'm not talking about quitting your chemotherapy. I'm talking about when the chemotherapy hits its plateau, these supplements can help push the mitochondria of the last 1% of the cells to self-destruct, which is the goal of chemotherapy and radiation.
So would it be kind of like what they're doing now, using vitamin C in combination with chemotherapy to keep the person healthier so that they can survive through the chemo process? Or is it even more indicative of actually helping kill the cells?
This is actually helping kill the cells. There are a lot of things you can do with supplements to help the person stay healthy. And like I also said earlier in the program, a lot of medical oncologists are shy away from that because it's completely outside of their realm. It's a little odd, that you have doctors of naturopathy who know a great deal about all these things not being incorporated into the healthcare system. And a lot of people will say cynically that we don't have a healthcare system, we have an illness system. And part of the reason why naturopaths and chiropractors are successful is because they address these issues for people who want to stay healthy and want wellness. And it's particularly true for my generation, boomers, who want to keep going and don't want to just give up when they're 60. And so anyway, the supplements that I'm most interested in are non-toxic, but they take advantage of the fact that the mitochondria of cancer cells are vulnerable in a particular way that we can manipulate with non-toxic vitamin-based supplements. And I've been starting to use those in patients, and in a couple of cases have had rather dramatic success.
Would you consider the use of this new combination of supplements along with chemotherapy something that will be available in the near future to the public, or something that they're at least even doing trials on yet, or is it this kind of just pie in the sky still?
Well, I have to be honest with you, just so the listening audience won't think that I came from outer space. I didn't invent any of this. These supplements have been used in phase 2 clinical trials in universities in the United States and were shown to be effective and non-toxic. And the FDA did not approve phase 3 trials to continue the research without any explanation that I know of. So I have to tell you that if you talk to 100 medical oncologists, if one of them was me, then the other 99 wouldn't know anything about this. I didn't know anything about it until I finally decided to go looking in the briar patch for Brer Rabbit, because I kept looking in the woodpile my whole career and he wasn't there.
Well, this appears to me kind of like the woodchuck saying, don't come into the briar patch or I'm going to chew your butt up. And we really don't want to see that type of a therapy, because it's much better to have the drugs and to have the oncologists do what they're doing now. Number one, because it's more expensive. Number two, because that's the way we've been doing it for years. Is that kind of where we're going with some of this?
Well, you have to understand that in science in general, paradigms are very hard to break down. It's just the nature of the beast. I like to tell people that Albert Einstein was mocked by his contemporaries because they thought his ideas were stupid and because they were so weird and so different. And, of course, we all know that he revolutionized all of science as we know it because he had a different idea about how the world works, and he turned out to be right. Medical oncologists have an extremely difficult job. They have to work within very narrow guidelines that are dictated to them by higher authority. And so they are, by their nature, careful, and they are reluctant to go outside of these boundaries. But that's particularly true of the young oncologists. But when I was a young oncologist, there weren't hardly any boundaries because 35 years ago,
you were a pioneer.
I was a pioneer. The cancer was a wilderness, and we were able to be creative with what we did. I'll tell you a funny story. I treated a patient with breast cancer some years ago who was failing therapy, and she was referred to me because people knew that I had some tricks up my sleeve, and I treated her, and she did really well, and I had a young partner. And he said, this protocol that you gave her, I've never heard of it, never seen it. I went through all the literature for the last 20 years, and I couldn't find it. I said, well, that's because a group of us came up with this protocol at MD Anderson 30 years ago, and we know that it works. I've seen it work, and it still works. And he was flabbergasted that you could actually practice in that fashion. And that's what I enjoy doing.
Well, I think what you're doing is probably one of the more interesting things that we have had come on this show in talking about both the supplements and the light therapy. You're going to be doing these trials up at the Karlfeldt Center. Is that correct? So if people want to talk to you about this, they can give you a call there?
Right. I am my only physical location in Boise is at the Karlfeldt Center. And I'm available for appointments there to talk either about second opinions regarding cancer or supplemental therapy to augment your chemotherapy regimen or to discuss use of the light machine for either chronic fatigue or viruses or autoimmune diseases.
Well, I want to thank you very much for joining us this evening, Dr. Ickebane. And offering your insights into photoillumination and some of the newer things that are coming up in therapies. This is Bob Neugebauer saying good night for Healthy Conclusions. We hope you will join us again at the same time next Sunday for another hour of informative talk about nutrition, exercise, alternative medicine options. We are sponsored by Altrua Health, share.org on 580 KIDOAM and 107.5 FM.